We're looking at this graph, and we don't have a TI for this. This is our velocity graph, so I am going to make note of that. And we have a particle, or we have an object moving horizontally from 0 to 8 minutes. At time 0, the object is situated at 3 feet, so x of 0 equals 3 feet. That's my starting position, and we're moving along the horizontal axis. Okay, so part A, at t equals 2, which way is the object moving? If you recall, the object is moving based on the sign of velocity. So you want to find the velocity at 2, and in our case, the velocity at 2 is -2. And now, we don't really care about what value it is, we just care that it's negative. So we're going to say, which way is the object moving? Left, because the velocity at 2 is less than 0, or negative. Okay? Part B, at what time other than t equals 0 is the position of the object at 3 feet? Very interesting question. What we're talking about here, the object starts at 3 feet. That is our starting position that was given to us in the problem. What I want to know is, when is it back at 3 feet? So if we follow this graph here, the velocity is negative, therefore my particle is moving to the left. So I start at 3, I move to the left, and then after 3 minutes, I stop and I start moving to the right. And I want to know, when am I back at a position of 3 feet? So what I'm actually looking for is a displacement of 0, because the displacement means where are you from start to finish. If I start at 3, I want to finish at 3, that means I want the displacement to equal 0. Now, how does that relate to this graph? The displacement is the integral of velocity, okay? So the integral is the area under the curve. So I want to know, when does the integral equal 0? That's when you have equal parts above and below the x-axis. So if you follow along this graph, I'm moving to the left, I'm moving to the left, I'm moving to the left. So we've actually moved to the left. If we look at that, let's see if I break this up. This is 4, and then based on, so this is a unit of 1. So I've moved to the left 5, I don't know what our units are, 5 feet. So now I'm starting to move to the right. Am I back to where I started yet? No. Here? No. Here? Yes. If you look at this right here, you have the equal areas above and below the x-axis, so that means that your displacement is going to be 0. If your displacement is 0, that means I started at 3 feet position and I'm right back there, okay? Now, what we have to be careful of is we have to keep looking at this graph. So now, right here, I'm back at a position of 3 feet because the displacement is 0. The area over and under is equal, so that displacement is 0. So now I'm moving another, this triangle here has an area of 1. So now I moved 1 more foot to the right, but look at, you end with moving 1 foot to the left. So you have a displacement of 0 over the course of this entire graph, which is our 0 to 8 minutes. So from 0 to 3, 4, 5, 6, at 6 minutes, I have a displacement of 0. And then again, at 8 minutes, I also have that displacement of 0. So I'm going to say, for this answer, at what time other than 0, because we start, is the position at 3 feet? At t equals, what did I say, 6 and 8 minutes. And why are we there? How do I explain that? Because the displacement is 0. So I start at 3 feet, that's my starting position. If the displacement at 6 minutes is 0, then I'm back at 3 feet. And if at 8 minutes the displacement's at 0, I'm also back at 3 feet. Okay? Part C, When is the object at its furthest right? And what is its position at that time? So again, I mean, what I'm doing, and I really did this for the previous question as well, I'm picturing a snake diagram in my head. Okay, I'm following the path of this object that's moving left and then right and then left again. So I'm thinking of that in my head. So if I go back to the beginning, my object starts at a position of 3 feet. It's moving left, okay, so I'm moving to the left 5 units. Then I start moving to the right, and I move to the right 6 units. So I'm past where I started, if that makes sense. Then I move to the left again. So this particle, without doing a very rough sketch of this, my particle starts at 3 feet. It moves to the left 5 units. So that's at -2. Now it's moving to the right 6 units. Now I'm at 4 feet, and then it moves to the left again 1 foot. Okay? So this is the path of my object. So this is what I have going on in my head. Might as well put it down on paper. And if you look at this, when am I furthest to the right? So you're looking at when are you furthest to the right, and that's right here. That is, and if we go back to our graph, we're talking about this point on our graph. So that's at 7 minutes. So when is it furthest to the right? When t equals 7 minutes. What is the position at that time? The position at 7 minutes is 4 feet. So that's what we got right there. And I'm hoping if you look at this snake diagram, you can also see how your answer to B fits into that. I started at 3, and then you know that I'm going to be at 3 again, and then at 3 at the end. So those are all of my answers. This is my 6-minute answer, and that's my 8-minute answer. So hopefully that snake diagram really spells that out for you. Okay. Part D, what is the acceleration of the object at 2.5 minutes? If I want the acceleration at 2.5 minutes, I want the derivative of this graph. That means I need the slope of this graph. So this really means I need the slope of the line at 2.5. Because we have an actual graph, we're not just going to say that it's positive. We're going to get the actual slope. This line segment here has a slope of 2/1. So that has a slope of 2. So that's the acceleration, and don't forget your units. So there's my acceleration. Explain your reasoning. Okay, so how did we get that answer? We found the slope, which is v prime at 2.5. Okay. Part E, is the object slowing down or speeding up at 2.5 minutes, and justify your answer. If you recall, we have to look at the signs of velocity and acceleration. The velocity at 2.5 is negative because the graph is below the x-axis. The acceleration at 2.5 is positive because the graph is increasing. Therefore, the object is slowing down because the velocity at 2.5 is negative and the acceleration at 2.5 is positive. Okay, when they have different signs, that means that the object is slowing down. Okay, and the final chunk of this question right here. When is the object at x equals -1 feet? And explain. Okay, so this is very similar to that new position. Only difference is they actually gave us the new position. I want to know what the time is at that new position. When? We have to find t. When are we at that position of -1 feet? So I'm going back to my new position formula. They gave us a new position of -1. My new position is equal to my starting position plus the integral from 0 to whatever time I'm at that position of v of t dt. okay? Now, I always say that your lower limit should match this, and that your upper limit should match your time out at the new position. I'm looking for the time. They gave me the new position. So -1 equals, the starting position is 3. They gave us that. Plus, whatever this integral is, this is what I'm looking for. So what I need to know, I need this number here to be -4, because that would make this a true statement. 3 plus -4 would give me a new position of -1. So I want to know, when is this integral equal to -4? That means I need there to be an area under the curve, because that's what the integral means, of -4. So if we go back to our graph, and I look at this, when do I have an area under the curve of -4? If I look at this and just following along, that's an area of -2. There's my -4 right there. So at 2 minutes here, I've got an area, an integral of -4, okay? So I have t equals 2 minutes. Now, if you look at your snake diagram, and this is where I think the snake diagram can be very helpful, if you just kind of spot this, I'm talking about a position of -1. If we're talking about a position of -1, that happens 2 different times. So that's clearly happening 2 different times on my snake diagram. So I need to find out, what about that other time? So if you look at your graph again, okay, after 2 minutes you have an integral of -4. Here, now I have an integral of -5. But if I go 1 more minute, this +1 and the -1 cancel, and you again have an integral of -4, okay? So my other answer is at 4 minutes. That's what I want to get down here as well. 2 minutes and 4 minutes. Why? Because the displacement is equal to -4, and that's what I need for that integral to work. I need to have a displacement. I need that integral to equal -4 so that this works out. I have a displacement of -4 at 2 minutes and at 4 minutes. So there's your final answer. Hopefully that went all right.